since COVID has hit our lives. And we continue to expect, wish more was done about it. And we are really excited to know how federated learning can probably make a difference in this space. So I'll be handing out to Raghavendra and Shreyas. They'll take us through challenges that they faced and probably give us ideas on how to overcome, work around federated learning for the space. Over to you.
Yeah, thank you. So quick introduction, both of us, you can call me Raghu. Myself and Shreyas, we are from Intel. We have one more author to this paper, Sandhya. She couldn't join us. So as Shruti rightly said, so COVID time is when a lot of work happened around healthcare. But before I start with the contents that I have, I mean, maybe quick pulse check in the room. How many of you have had hands-on experience with deep learning, or at least some familiarity with deep learning? Okay, that's good. I think maybe that's an obvious and a stupid question at some level. And second, how many of you have had background in healthcare, or at least been looking at healthcare? Okay, that's also good. So feel free to stop me anytime if you have questions. Right, let's keep it interactive that way. So the paper that we did, it had three parts. The first part talked about how AI is being used in healthcare, and I think that's a given. All of us know that there is a lot of work happening around the world when it comes to applying AI, some of the deep learning techniques, the latest state-of-the-art algorithms, to healthcare. The second part of the paper talked about the challenges that limit taking whatever is done in the research space to actual field, right? I mean, it's one thing to get accuracy in your lab, accuracy of 95%, 97%. Put it in the hospital, immediately the accuracy drops down to 60% with real data, right? Why is that the case? And third, we will talk about federated learning as to why that actually promises to be a means, and I'm not saying the only exclusive means, but one of the strong candidate to address that particular challenge, right? So first few foils, so I'll just kind of go in the same order. The first few foils talking about the first part, but the majority of the part is about the challenges in deep learning around data, and then the federated learning. We also did plan a hands-on tutorial, to kind of take you through as to what does it mean to run a federated learning experiment. Now the laptops have changed. We are kind of on this laptop. Plus we've had some issues with the Wi-Fi. And I'll tell you why the network is extremely important in federated learning. So I don't know what we can do, but maybe we can talk through the GitHub that we have, the code. It's all open source, right? And you can have a look at it, run some of those experiments, and then feel free to connect back to us if you have had any issues and questions on it. Okay, so I think given the background in AI and the healthcare in the room, I think I'm kind of preaching to the choir to say that healthcare is one of the technologies that is being adopted in healthcare very strongly. This is a NASCOM report coming in 2019, and I purposely wanted to pick 2019 because post that COVID has changed a lot of things. But even before COVID, we did have a lot of interest in applying AI to healthcare, right? So if you see, hopefully this works, the artificial intelligence, in terms of the adoption curve, it's quite high. Now, let me tell you one thing though, that, a lot of this adoption that they talk about is, research to applied research. Actual deployment is pretty limited, right? I mean, COVID did help, kind of accelerate that a little bit, but still that problem statement is true. But in terms of the healthcare industry looking at AI, the interest is quite high, right? And among who is applying the most, obviously the private hospitals and pharma. Again, this is an India landscape, right? Private hospital, pharma, private hospitals, it would be your Apollos and Manipal hospitals, for example. I know that, in fact, one of the meetings, kind of went into a room with Apollo hospital people in there, and all of them said, doctor. I said, okay, all medical doctors, but turned out all of them were PhDs with deep background, right? So they are investing in hiring people and doing stuff, right? And they have collaborations with the technology companies and doing stuff, right? But as I said, going beyond research into active deployment is a totally different ball game. And this particular challenge that I'm going to talk about is pretty unique. May not be exclusive, but pretty unique to healthcare in terms of, the access to quality healthcare data, right? So that's the challenge. How do they get access to quality healthcare data? Because when they're working in the research setup, they are on a particular data set that they have gathered. Of course, there's a lot of effort that goes into ensure that that data set is representative of the demography in which they're going to deploy it. But more often than not, the deployment always goes beyond the context in which the research has happened, and the accuracy just falls down, right? So a lot of the AI models, for example, in the Indian context, a lot of these AI algorithms, etc., they come, tested in the West, FDA approved, get it to India, and then it doesn't work, because the population is different and the data that it needs to be trained on is different. Right? Again, I'll send the deck. This is, and it's there on the USB, so you should be able to see it much more clear. Maybe a key takeaway here, right? I mean, what it says is, every single patient generates a lot of data, right? Now, it's not a dearth of data per se, right? There is a lot of data available. Walk into any hospital, you will see that data as such is not an issue, right? And that's because we collect data right from the womb till the tomb, right? I mean, nicely put that way. But every step of the way, right? Prenatal, birth registry, immunization, family physician records, dental visit. I mean, name it, and there is data, right? But so a single patient generates close to 100 megabytes of data in image and text. That's EMR, right, per year, right? That's significant data, right? 100 MB per patient per year, right? Image and text. Maybe image is a lot more size-wise, but it's there. But 80% of this data is unstructured, right? So there in itself is a problem statement. You're starting with a small subset of data that you can use, right? And out of that, 97% goes unused, for this reason, because look at each one of these steps, right? All of them are separate entities, right? And it's very rare that you're kind of connected. I mean, womb to tomb is not happening with one hospital collecting the data for that patient, right? You are going across multiple hospitals. You're going to a local family physician who might write it on a paper. So a lot of the data itself doesn't even get captured in a digital format that you can ingest into AI, right? I mean, you can use for analytics. So that's the problem statement. 80% of this data is unstructured, and out of that 80%, 97% of the data goes unused as a consequence, right? So which basically means that a lot of those AI deployment that we talk about is happening with roughly 3% of the data, right? Again, this is in India data. This is something that we did with PwC. We kind of spent time looking at the landscape of healthcare data in India, and this is what it turns out. In the Western world, it could be a little bit better than this, because the data is a little bit more structured, but it's still a majority of the data is still unstructured and goes unused, right? Maybe the percentages come down, 80% could become 60%, 97% could become 70%, but the problem statement still remains. And this is actually, again, a busy foil, but essentially what we wanted to convey is, so though there is a lot of data generated, given that there are multiple players, the data gets captured in different formats, right? So I'll give an example. A lot of this presentation, a lot of the material that we're talking about is consequence of the work we have done for the last 2.5 years. We went in with an assumption that it's all about looking at the AI algorithms, looking at specific techniques, and then applying it and deploying it in the hospitals, right? Where we hit as a roadblock is the data itself. So we worked with one hospital chain, Aster Healthcare. So it's a global chain, headquartered in the GCC in the Gulf, but present in around 8 countries, including in India, right? So we said, okay, let's start with Aster in India. So they are predominantly in Kerala, Karnataka, and a little bit in one hospital in Maharashtra, a couple of hospitals in Vijayawada in Andhra Pradesh. So we said, let's start with Aster. India, regulatory-wise, we may not have those challenges. We can start with it. But as it turned out, just ingesting the data between Aster Vijayawada versus Aster Bangalore, was a pretty big challenge because they were on different medical systems. Even for us to even read the data, it could be a SQL database, but one is implemented by IBM, another one is implemented by a company called Medif, right? You want to read the data, the kind of queries you need, are different. So the point is, you simply cannot go in with an assumption that data ingestion is pretty easy, right? I mean, you have data, just pack service is there, just read the image data. No, it doesn't work that way. So data producers, there are so many data producers, healthcare providers, of course, right at the top. But then, I mean, this is another one, right? Again, we don't understand the complex healthcare system. Even though Aster had all their EMR data, the prescription and the other stuff that you have, the brain of the hospital, so to say, the EMR systems, but the EMR system comes from another company, and that company manages it for Aster, right? Which means that even if Aster wants to get access to the data, they need to go to these folks and say, can you please get me that data that belongs to me? And depending upon what kind of a service contract they have with Aster, they will either get serviced, or they will say, no, you're not paying me enough to get fetch you that data, right? So the point is, so the EHR software folks also, they play a very key role when it comes to owning the data, right? And then there are all these other entities, including the government entities, and even in the Indian context with AHDM, etc., there will be a lot of data now that the government will kind of control, not own, but at least government as a custodian of the data, government will be a key player there, right? And then there are intermediaries. Of course, there will be intermediaries because there is a producer and then there is a consumer. So somebody has to play the middleman role, and that's where the intermediaries come in. Key ones, IQVA, for example, is one of the largest company which deals with data, right? They go around, aggregate data, accumulate data, keep it, and basically beneficiaries just need to talk to IQVA. A lot of this, for example, pharma companies may not even be talking to the hospitals. They will just go to IQVA and say, give me that data, and then basically use the data that IQVIA has. But the point is, again, the complex ecosystem in which that, first of all, data itself is unstructured, cannot be used as straight away. Then comes the complicated ecosystem in which the data is stored. All in all, what it means is that, again, kind of emphasizing as to why 97% of the data pretty much goes unused, right? So now, yeah, no, we'll talk. Yeah, you are right. So again, it kind of boils down to what kind of setup they have with the hospitals, right? See, I mean, except for the patient, everybody else in the ecosystem is a custodian of the data, right? So what kind of legal agreements they have, depends on the respective geographies, and accordingly the privacy laws. In India, only now we are talking about the privacy laws, right? And that too is going through its own multiple revisions. Right now, why exactly, kind of summarize this file kind of summarizes what I've talked about, right? So what are the key challenges when it comes to accessing healthcare data? One is the silos, the other one is the unstructured data. I talked about the unstructured data, but very quickly about the data silos, right? Today, every hospital that you walk into, they have their own storage wherein the patient data is stored, right? Now, how do you access that data, right? Either you send somebody to sit in that hospital, look at the data, clean that data, fetch that data, and then pay the hospital the money. And just imagine, right? I mean, just Aster itself has around nine hospitals in India, right? Manipal Hospital, just in Bangalore, with all the acquisitions they are doing, there are already 20 hospitals. It simply is not possible for anybody to kind of realistically go around and accumulate the data, right? So data silos are there because data is in the respective hospital premises, and then of course the unstructured data, and they contribute to each other. Because of the data silos, you cannot aggregate the data, and hence you cannot convert that unstructured to a kind of a structured data. So they are symbiotic in nature. Yeah, I mean, unfortunately, the colors are a little bit off. So what are the contributing factors? So under the data silos is where the privacy comes in. Maybe I'll just highlight. So privacy comes in because hospitals, at least, beyond, of course, there is a geographic boundaries are coming in India. Data, we are not allowed to now with all the privacy laws are coming in. GDPR in Europe, for example, right? You're not just allowed to share data beyond your geographic boundaries. So there are those regulations, but hospitals themselves are increasingly becoming very concerned on the privacy front, right? So they just don't share the data. So privacy is a key thing. Regulatory reasons, GDPR kind of regulations, which prevent what kind of data and how you share the data. The value of the data, right? Now, of course, 80% of the data, 97% of the data, I gave you that statistics, but hospitals do know that their data is valuable. So anytime an AI company comes in and says, I want access to your data, the question is why? What is the, and today the way it happens, Google has put out a lot of our IBM Watson, for example. That's a good example, right? So they've actually spent time with each of those hospitals, collect data, right? And once collect data has happened, hospital has no control on the data, right? Because it's already with IBM's, Google's, Amazon's, etc., right? But hospitals realize that data is like now sugarcane, right? I mean, the sugarcane, you don't pass it once and get the juice, right? You pass it multiple times and you get the juice. So data is like that. Depending upon what use cases turn out tomorrow, the same data could be used for some other purposes. So hospitals don't want to just give data away without them being part of that entire journey of what happens to that data. So the data value. And an equally important question is, how do you quantify data value? How do you know whether a particular record is worth 100 rupees or 1,000 rupees, right? So data value is a key question. The data size and data discovery. So data size is a key problem statement because some of your image data that you get from, so if you get a CT, that comes in a CD. Just imagine that the hospital's 100 MB per patient. Aster has 19 million patients coming to it every year. 19 million into 100 MB. Just imagine them being required to upload it to a cloud. Simply not possible, both from a cost perspective and the kind of storage that is required. They might need as many number of engineers to manage that, IT people, as the doctors that they have, right? And then the data discovery as such, right? I mean, given all of that, data discovery is a little bit more involved, so I kind of will not get into it, but it's a significant problem statement because, say, even if a pharma company, a beneficiary wants to come in and say, I want chest X-ray with this condition for this demography of patients, and how do they do it, right? Again, they need to go to each of those hospitals where it's most. So today, it's a network of, ground network of intelligence that they have. IQVIA will have some staff, who know the hospital chain in, say, South India, right? And they will know which hospitals has what kind of data. That's the intelligence that they tap into. So they have to rely on that human intelligence to even discover the data, right? But there is no way for them, like Google, get me chest X-ray with this. There's nothing that kind of gives them the data. But that's a little bit more involved. I'll kind of not get into the details there. But data discovery is a significant problem statement. Then comes the unstructured data, which I talked about. One that I'll emphasize is the lack of standards, right? So except for the image wherein there is a PAC server coming in and kind of saying, DICOM data, and then there is a little bit of standard there. For the rest of the data, there is no standard per se, right? Now, there is a lot of genome data coming through. Again, what is the standard there, right? Now, what happens is a big player, the first to the market will have their kind of structures, and that's what gets in. But again, there's no aligned standard to say this is how the data will be managed, right? So there is a significant challenge around the lack of. In fact, if you go to that NHS website, they talk a lot about the standards when it comes to healthcare data. It's pretty interesting area by itself, right? So all of that combined leads to this problem statement. So healthcare, I mean, AI for healthcare is absolutely required, but these are the problem state. I mean, as a consequence of the data challenges, these are the impact that you have. Poor AI model accuracy in deployment, right? Not in the research. It works great when you're doing it in the research lab. Model bias, because the data drift will happen, bias kicks in. So how do you protect against that? Lack of data, transformative. So a lot of transformative innovations, kind of get limited as a consequence of not having access to this data. And of course, poor collaboration and the time consuming today. Given that everything is relying on the network of people on the ground to go fetch the data. Right. So these are some of the use cases. Again, this is a consequence of the work we've done the last 2.5 years and kind of accumulated. And this is from revenue impact also, right? These are not use cases purely from people and impact in terms of these are the diseases or these are the use cases which, if treated, will help the population. It's not just from a population perspective, but also from a revenue perspective. These are the key use cases under each of the headlines, right? Healthcare providers, hospitals. These are the kind of use cases they have. Payers, these are your insurance companies, for example, right? By the way, the biggest use case that the government of India wants to kind of run on the ADHM is fraud detect, because of the insurance payout that happens, right? So fraud is a pretty big, fraud I think is a big use case irrespective of healthcare, right? Even if you go to banking, it's almost a 4-5 billion plus kind of a use case. Credit card fraud, for that matter, right? Then comes the life science and pharma. This actually is where the money is, drug discovery and drug efficacy tests. So cancer drug, when it comes out, right? I mean, it reacts one particular way on one patient, but differently on another patient. Why exactly does that happen? Now, this in turn has a lot of further kind of spreading its tentacles around in terms of digital twins coming in, because they can't get patients to do simulations on, right? Because the conditions are so complicated that you cannot just select patients and do some of those drug efficacy tests. In fact, one of the biggest hindrance today to bring it, except for the COVID vaccines, every other drug takes 8 to 9 years to come to the market, right? And 50% of the time is because of the patient selection, patient dropouts. The drug efficacy does not really happen for that reason, right? So digital twin kind of things are coming through there. And then finally, the patients themselves, right? So prevention and monitoring. So monitoring, by the way, is a big use case also, right? Especially for the geriatric patients, right? The old. And even in India, Apollo is focusing heavily on that because there is a sizable NRI population with parents here, them there, and they want to track their parents remotely, with cameras enabled and all. So Apollo itself is running a full program on that. Okay. So again, now this kind of jumping into the specific work that we have done, right? So that's a problem statement, right? We did not start with federated learning. We started saying healthcare, we kind of look at the problem statement and see what we can do with the healthcare data. And we started with certain conditions, health conditions as a focus. But as it turned out, data itself is a key challenge. But the data silos being a significant, so there is data silos and there is unstructured data. So we are not talking about unstructured data problem yet. We are talking about the data silo problem statement right now, right? So we looked at federated learning as a very strong candidate, right? I'm not saying the only way, but a very strong candidate to address this problem statement with respect to the data access, the distributed data access, right? Because of the data silos. So how many of you have heard about federated learning, by the way? Okay, so then again, it's pretty easy, right? So maybe I'll just focus on one key takeaway: privacy and security, right? Now, given that it's a distributed access to the data that happens, your attack surface increases, right? So there is a privacy part, of course. Anytime you access data, privacy comes in. But now security also comes in, because if that data falls into a spurious hands, then there is at least there is an issue, right? So privacy and security are the key challenges that needs to be addressed if in case you are deploying federated learning based training mechanism, right? And healthcare is a very strong candidate. Maybe I'll skip a few of these interest of time. I think given the audience is familiar, but this actually is mainly to say that federated learning as such has no limitation with respect to the kind of data that it can work on, right? Now, if you have an AI model that can ingest those kind of data, federated learning can certainly go and work with that, right? But of course, what kind of algorithms you can do aggregate with federated learning, there are some open areas. For example, GNNs, graph neural networks, we have still not had this research area, let me put it that way, right? So how do you aggregate models when it comes to federated learning on GNNs or reinforcement learning, for example, right? Again, it's more of a math related challenge there. How do you aggregate and not lose on the accuracy? But otherwise, purely from a data perspective, there are no limitations, right? And at least for most of those image and text data, the kind of models that we have, CNNs, RNNs, transformers, etc., that kind of works fine with federated learning. So this is very quickly, maybe a terminology thing, right? Since you're aware of federated learning, maybe just to introduce a few terminologies, because that's what we are using in OpenFL, which we'll talk about, right? So there is, each of the hospitals, participating hospitals, we are calling them collaborators. And so what happens with federated learning, as you all know, we start with a version of the global model, which is sent, a copy of which is sent to each of the participating hospitals, collaborators, and they train on their local data. So there is no data moving out of the hospital. So the global model, so it's more, instead of moving the data to the compute, you move the compute to the data, right? You're kind of switching the role. Right, so each of the hospital, the collaborators train locally, right, and that global model is sent back, and that gets aggregated, because now you have three versions of the same global model, and you need to aggregate, right, and you aggregate it on the aggregation server, the aggregator, and this iteration keeps happening until you hit a certain convergence or an accuracy. Right? That's what federated learning is, and terminology wise, collaborator and aggregator. So as I was saying, that's not the only way to deal with distributed data, but we have done some work. This is coming from a paper that Intel has published. I think there are references in the deck, wherein we have kind of compared it with centralized data sharing. This is the ground truth, right? Wherein you are able to aggregate all of the data and you train on that data, right? So that's the ground truth. Compared to that, how does institutional incremental learning, right? So wherein your global model, you pass it through each of the institutions in a serial way, right? Again, there are challenges or open items in terms of A, B, C, whether it has to be ABC or BAC or CBA. How do that also kind of has an influence on the kind of accuracy you end up with. But institutional incremental learning, it's like a serially you go through. Then there is a cyclic, which is same thing, but you repeat a number of times, and compared with federated learning, right? And this is what we ran into. Again, the graph, the colors are all messed up. That's the paper reference that I talked about. But and as I said, there is this is a centralized training, the ground truth, and this is the black line. If this is black line, right? So that's the accuracy. What you have is, it trails a little bit in terms of how fast it converges to that accuracy, federated learning, but it does get to that kind of an accuracy, right? If you see, whereas all the others, because of the fact that it passes through the institutions, and then you kind of hit into some of those fundamental data learning problem statements around catastrophic forgetting, class confusions. It kind of oscillates. It's not like a steady line. The federated learning gives you a steady line, but this kind of oscillates, right? And accuracy also is not there. So this is what kind of told us that federated learning is something that we should bet on, as Intel I'm saying, right, and not in general. And that's what we have done. That which kind of took us to some of the largest in healthcare, at least largest federated learning project to date is what we have done with UPenn and this is across 71 institutions, hospitals, and academic research institutes, 6 continents, except Antarctica. And what we have seen, and this for brain tumor, right? How well you are able to detect brain tumor, right? At least segment the tumor, right? So this one actually gives you 33% improvement. Now, this is no magic per se, right? More access to data means better accuracy. That's what it is. But what we are doing with federated learning is getting you access to that more data, right? Otherwise, there is no secret. If you were able to get all of the data in the same place, if you are able to walk into each of those 71 institutions across 6 continents, copy all of the data, get it to a central server, train it, you will also hit that 33% improvement. But because you cannot walk to those 71 institutions, across 6 continents, you need federated learning. And with that, you get we got a 33% improvement, right? Yeah, and what is that 33%? There is, but there is a reference to the paper again. So this came out 2 months ago, right? And this has been acknowledged even by the White House, right? Because this is significant. One of the largest medical federated learning project to date, right? Of course, somebody can do new stuff. So from a federated learning terminology that I introduced, there are 71 collaborators and there was one aggregator. UPenn was the aggregator. But from a physical compute perspective, we depends on the hospital's infrastructure, right? Because in terms of one of the biggest challenge in this entire federated learning deployment, even with Aster, is the IT team in the hospital, right? I mean, you can convince the doctors overnight. Convincing the IT team takes 6 months, right? Because and naturally so, because the data is, they are responsible for that entire hospital. They cannot. In fact, I'll tell you one funny. Just 1 minute. We had to actually work in the night to get access to that data because they said, nothing touching my live system during the day because I don't want your traffic to clog my network, right? So we were kind of sitting up through the night and then getting access. So in terms of how many nodes, minimum 1, but then it depends on the IT in setup in terms of how many we end up with. Plus there is an element of security which I'll come to, right, which actually increases a little bit. Yeah. Yeah, so that actually is also an area of research right now with respect to the non-IID, right? Data distribution and how do you address the data distribution, right? But in terms of the that graph that I showed you, right? So given that is actually under, again, that paper that I referred to in the previous one talks about that heterogeneity, right? Now, heterogeneity is again a broad term. What level of heterogeneity are you talking about? Federated learning also has horizontal, vertical federated learning, right? We are mainly doing horizontal federated learning. Vertical federated learning when you are combining multiple data. So all of that complicates your heterogeneity is again not from just one data, right? Again, maybe I'm kind of confusing you, but the point I'm saying is today, healthcare AI models, the impact of AI is not just from one type of data. It's multimodal data, you need to combine. So we talk about longitudinal view of the patient, right? I mean, I don't want just one CT scan of the patient. I need what has happened to the patient, say, 2 years prior to that CT scan, right? If that data is so longitudinal access to the patient record. So there is text data, there is image data. Now for precision medicine, we are also adding genome on top of that, right? Because the genome sequencing is done. So the point is we are talking about multimodal, right? So combine all of that, the heterogeneity question also kind of blows up, right? But even for the same type of data, even if you're just talking about image data, right? So that paper talks about, based on certain heterogeneity classes, federated learning actually does get to the same kind of accuracy as centralized training. The convergence is what gets impacted. It will be slower as compared to, but how slow is what the question is, right?
What I'm getting from this question is about the device heterogeneity also, right? Say CT scan from different machines.
Yeah. Well, again, you can introduce a lot of variables and not do any experiment at all. The device heterogeneity is more a function of the stack you're developing, right? So, for example, what this essentially means is there are fast devices and there are slow devices, stragglers versus the fast. How do you handle it? Asynchronous versus synchronous. If it is asynchronous, how do you deal with it, right? So that's what it kind of boils down to your federated learning stack, what kind of capability have you added in, right? But that's not a fundamental problem statement. No, that actually is a problem statement on the data, right? So now 71 institutions, it took us around 2.5 years to kind of sit, and then we developed certain tools to even convert the data into a common representation. Yeah, common representation. Right? We have actually spent that time. Otherwise, it would have been overnight effort, right? I mean, we spent 2.5 years for that reason. This is brain tumor. So if you have a CT scan, it kind of predicts your tumor area. So what a radiologist does, right? I mean, you have a unit models. If you have heard, it's exactly the same model. Think of the same model. You are training it on federated learning. With federated learning, you get 33% better as compared to state of the art. And it's not anything to do with federated learning, right? It's only to do with the fact that you get access to more data. That's pretty much the magic here.
It uses only image data.
Sorry?
This model uses only image data.
Only image data, but it gets access to more data as compared to any other prior work that has been done. And that's why that 33% comes in. This is one of the methods to distributed training. So what I talked about, institution incremental learning or cyclic IIL, is all different other formats of this. Even federated learning, network topology wise, you can think of it in different ways. You can do it in different ways. Right? Here we did it with one aggregator in UPenn. Now you can have multiple aggregators. So there are different network. I mean, that's what I said. You can add more variables and complicate it, but we kind of said with one aggregator and 71 collaborators, this is what it is.
Apart from the practical difficulty of collecting all data in one place, so what is the absolute purpose of using federated learning in this case?
It's mainly the data silos.
Yeah, but if I have all the data in one place,
then you don't need federated learning. But if is not a small if.
No.
Because we spent 2.5 years and realized that's not happening.
In this case, this 71 there is no transfer of
no data is leaving those institutions.
No, transfer of patients. Say I do a CT scan on the first institution and I do it on the second institution.
There is no transfer of no.
So then nobody works, right?
Yeah.
Otherwise, longitudinous actually falls.
Yes.
What about annotation? So are the original institutions actually annotated data?
Yes. So we actually sat with at least a few selected. UPenn really helped a lot because they had the network connects and the resources to influence the other institutions to sponsor resources and all. So we had annotated data.
And the annotation was at the level of this particular patient has brain tumor or actual segmentation of the tumor, or
segment. So ground truth had all of that annotation. Yeah. In fact, as part of that, we developed a tool which each of those institutions, UPenn developed, developed a tool which each of those institutions used to kind of qualify the data annotation and then even anonymization, annotation, and then basically have the record.
Retraining this whole thing. I mean, when you look at prediction drift, things are going bad. So will you see that, I mean, is it one model that's getting replicated everywhere, or do you see that drift can happen at different places at different times?
It's a very good question. I mean, again, multiple layers to that. Very good question. Even with federated learning, right? When it comes to it, so at the end of it, for example, we did an experiment with Aster as well. I give an example and I'll come back to your question. We did it with Aster across 5 hospitals in south of India, right? Four hospitals, Kerala and Bangalore, and then 1 hospital in Vijayawada, right? So the data that we had some common data and then some unique data, right? So Bangalore had some additional unique images compared to Vijayawada, right? So the model, when it was trained on the Bangalore data, we got to an accuracy of around 83%, whereas Vijayawada was not, there was no other unique images. So your 67% baseline, 63 became 67, right? So the doctors in Bangalore can very well say, why don't I just use that 83% because it's a better representative of my thing as compared, instead of a global aggregated, which is 71%, right? Because so federated learning also has multiple pieces of open areas in terms of aggregation algorithms, right? What we use is a Fed average, the weighted Fed averaging kind of kind of an algorithm, right? And there are multiple algorithms there too, right? So what it means is the hospital in Bangalore can say, I'll use that 81% compared to this, right? Which actually led to, I'll kind of cut short and then directly jump, but we can offline sync on this.
Sure.
cut short, that led to something called continuous learning, because you have these models. The models are also locally getting updated at say Bangalore, at Vijayawada. Then you aggregate it again. So there is something called FCL. It's again, if you track NURIP's papers, FCL is one of those
Right. No,
areas.
these are it's a very
Federated
interesting
continuous
area. Yeah.
So,
Sure.
yeah. And in fact, federated continuous learning is a problem statement not just unique to healthcare, across, right? Even in retail, we are actually, kind of, because every shop will have its own, items, which is not the same across. So you need to kind of, new class comes in, how do you add and then aggregate?
Right. I mean, we see it the same problem in other domains as well.
Yeah.
So that's why I asked.
So FCL is what it is.
Yeah.
Customization, of course, even with federated learning. See, the point is this, right? I mean, with federated learning, again, using the Aster or maybe this example, right? Instead of starting with a model which is 33% lesser accurate, you're starting with a model which is 33% better off. But even with the 33% thing, maybe there are certain hospitals in those 71 which kind of got 50% accuracy, and that's where the customization comes in, right? So fundamentally, to that kind of adds more variables to this problem statement is we are working on a deployment of some of this in a retail context, not in healthcare, for different reasons. And there, what we realized is, when it comes to deployment, of course, DevOps is required, but on top of it, proper data ops and ML ops is required. Otherwise, I can't deploy any of this. Yeah.
The IT department that you are only carrying the weights and not the data.
So, so there are.
We face this problem every day. So
Yeah.
just wanted to
Yeah. So actually, there are. I'll give you 2-3 answers there, right? One is, we showed the Intel badge. They said, what is Intel doing in healthcare? Anyway, you guys won't do anything in healthcare, so we trust you, right? So had it been Google or IBM, they wouldn't have been so forthcoming, right? One is that, we were Intel and not Google or Amazon, because compute. What else? What more will you do? Because our interest, which we are not talked about, is a security part of it, right? So I'll talk about security. So one is that. Secondly is, that's what I said, even with Aster, it took us 6 months to kind of, convince the IT team, right? And it kind of, finally we said, you run your audit, whatever hooks you want to kind of audit and confirm, you do it. But what happened in Aster is it was all within their network of hospitals, right? So it was not like the data was leaving the institution. I mean, the weights were leaving the institution, right? Aster Vijayawada, Aster Kerala cluster, Aster Bangalore, but all within Aster network. So they were okay even if there is data leak happening, they were okay with it because
so
it
you
was
mean to
within
say
Aster.
the federated learning happened within their perimeter network?
With what we did with Aster happened within, but this UPenn is across different independent 71 institutions across those 6 continents. And there it was mainly, we sitting down and sitting and talking and convincing, plus any kind of audit, right? So OpenFL stack had enough hooks into it, which you can tap into, which IT team could tap into and then see, right?
But
Again,
there is HIPAA compliance which will ask for all these
yeah, but this
safe
is a
harbor.
pilot. We did not go all the way there. It was a pilot that we ran, right? But then also on the network side, in terms of what ports are open, right? There were no ports required to be open on the hospital side, right? It's only the aggregator which kind of they connect to and then do it. So there are a bunch of things that we have done to kind of allay those concerns. And more importantly, the security, right? So the last piece of it is a few more faults. I'll talk about it. Okay. Security that comes in.
Good afternoon, sir. So basically, my question is like there are 71 models which comes from 71 institutions. If we do like hyperparameter tuning or there is a dropout, so they're like the parameters are changing in all the models. Like some have 15 lakhs, some have 20
No,
lakhs.
here
It
all
is
of them have the
different.
same kind of hyperparameters.
So how? Okay.
All of them have the same kind of hyperparameters. Not we use the same hyperparameters across all.
Okay.
Again, it's as I kind of said, managing the variables. Theoretically, yes, I can kind of say that data, the distribution is a little bit different, and hence I need to do a little bit more rounds or epochs at that particular institution. But managing complexity is what it is. We said it's the same hyperparameters for all. But then you can have, but if you say that you need to have multiple different hyperparameters based on some intelligence you have on the data or whatever, then you're also talking about multiple aggregators and all, the topology changes. But here we kind of manage the variables and said we're not really doing all of that. All of them have the same hyperparameters.
Okay.
Aggregator is the model owner. Aggregator decides the model.
Yeah.
And others are the data owner. Would not have a say.
So what do you? It's open source. I mean, and open. And I'll talk about. There's a few more. Yeah. 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 So quickly, there are federated learning is there are a lot of institutions which are already kind of working on it. Stacks outside. I mean, already put out, right? And these are some of the examples. We have personally worked with. Of course, this is ours. We have worked with PySwift, NVIDIA, Clara, and TensorFlow federated, right? And all of them have their pros and cons, right? And Intel OpenFL, we addressed the security related challenges, which I'll talk about in a bit, right? Any other questions? Right. So which brings me to OpenFL. The word open there is indicating that it's open source, FL standing for federated learning. So this is an open source federated learning stack by Intel. Right. In fact, we were one of the first to open source the federated learning stack. Right. I mean, after we did, 6 months later, NVIDIA also open sourced their federated learning stack. The key differentiation is this piece, right? I'll just, in interest of time, I'll just kind of highlight the key ones, right? The privacy preserved machine learning for data model in transit uses and storage. So the key thing that we are focusing on is the security and privacy piece, right? And that's extremely important because, as I said, with federated learning, the attack surface increases, and unless until you are able to convince your hospitals, the data custodians, on the security and the privacy aspects, nobody is going to deploy it, right? So that's what we have been focused on. Anything else? Yeah. So core values, scalability, security, developer experience, right? Now scalability is because, once I have that network of, say, I have the federated learning network established across those 71 institutions, it's not like I can run only one experiment at a time. I can actually run multiple experiments, different experiments on different kind of data sets, right? So one is that scalability. The key one, is the security, right? Protection of both the IP, the hospital's IP, which is the data, as well as the AI company's IP, which is their AI algorithm, right? Now, as I said earlier, the model is being sent to each of those hospitals, right? So which means that the model, which is the IP of the AI company, is now in the hospital premises. If they get access to that model, the weights, in a way, the secret is out, right? So how do you protect the model when it's in the hospital premises? Converse is the question that you asked in terms of how do you guarantee that there's no data leaving the hospital, right? So that's what it means: protection of IP of the AI model as well as the data set itself. And finally, the developer experience, right? Again, I mean, that maybe we can talk through when we do the code walkthrough, right?
One question, like if you add a new node itself, today you did with 71 institutions, so 72nd come, then how do you do it? It's a fresh coming in, right? It's not the new data as per se, but new
Yeah, so at least today OpenFL does not support say experiment is ongoing and you introduce a new one and say add this new node also. So today we don't support that. Correct me if we don't support that. Some of those stacks that I talked about earlier, they support it. I think Flower, which is not listed there, that supports. Flower supports it. There's Flower. Right, so that supports. Flower supports. I think NVIDIA also supports it. I may be wrong, right? But for the security, yes, because that was the Intel differentiation. Otherwise, you can run it on any hardware, right? So by the way, right, even though it's coming from OpenFL, a lot of our testing happened on NVIDIA GPUs, right? Because you want to kind of test as to how the federation works, and you need certain accelerators there. But when it comes to security, that's where you cannot just do it anywhere. You need to do it on on Intel hardware, because we give hardware guarantees on the security, which we talk about in the next few calls.
Sir, excuse me, sir. Saying that a skeleton architecture is created by the aggregator and it is distributed to the data provider. Sir, on what basis is this skeleton architecture is created when the aggregator doesn't have any kind of data? So how the aggregator is thinking that the architecture that is being created, it would work with any of the data provided by the 71 institutions?
So I'll start with a pretty non-engineer kind of an answer to say that that's not a federated learning's problem statement, right?
Okay,
that is a problem statement of whoever is bringing an algorithm to be trained, right? In terms of what is the weights that the model has been initialized on, right? So strict. I mean, in practice, what we recommend as a deployment is you say you have a certain corpus of data available publicly or otherwise, which is where you need to start and train centrally that model to a certain accuracy. federated learning is mainly addressing the challenge that when you take that model and deploy it, the accuracy falls, right? So what we are saying is use federated learning, get access to data that you otherwise cannot get access to, incrementally train that model with this data additionally, right? And that new model is what you can use because that will be that much better, right? So that 33%, the 33% improvement in brain tumor segmentation, that minus 33% is that model with only centralized data. Plus 33% is with distributed data, right? So strictly speaking, from a deployment perspective, the recommendation is don't start with any, zero weights or whatever. Of course, you can start with some random weights and then, it will converge. I think we have done some experiments also, Shreyas, we want to talk about it. Yeah.
So started with random weights versus started with training on versus training on the chest X-ray images from
ChestNet image. There is a publicly available ChestNet
on chest
model.
X-rays, right? So started with that. The one is the convergence. It takes a lot of time when you start with random
initialization.
And second is we also saw some particular, very curious things, right? As in, it's not repeatable in terms of, say, you start with random weights versus this one. You might hit a jackpot a couple of times on it being closer to what the results were on with the chest X-rays, but like you said, start with something you know.
So with random weights, not recommended because the reproducibility of the experiment is a bit of a question mark.
Okay,
right?
okay, sir.
So again, there might be some answers to that, but we have not spent time digging into as to why that's the case, and we have not spent time on that.
So one more question is there. The UPenn that you were talking about. Hello, UPenn is actually collecting a generic form of data or any specific data?
It's not collecting any data.
You were talking about. They are actually working on any disease specific, like
brain
the
tumor.
brain tumor.
Yeah, brain tumor.
Okay, okay.
So your MRI scans, CT scans, that's the data we are working on.
Okay, okay, okay. Okay, sir.
There as well, right? So the initial training was done on the Bratz data set,
publicly available data set, and
on
then
the UNet model, and then that was the initial.
Yeah. So federated learning is addressing a problem statement, right? Now doesn't mean that you can do away with whatever is already available. Publicly available data, please start with it, train centrally. That model you improve, get that 33% boost using federated learning because you get access to that data otherwise, which is not possible.
Are you aware of any other data being trained on like genomics data or any omics data?
We have not done the omics yet, omics yet, but there is an undergoing effort. Maybe one other time I can come in and talk. There is an effort underway. The omics, the problem statement with omics is, in terms of the use case themselves, right? What use cases are you going to apply with omics data? That use case itself has to evolve. Now, once you kind of have some baseline model with certain accuracy, and want to improve the accuracy further, that's when federated learning comes in, right? So that's a work underway, but I don't have results today. I can only say that we have started, and this 4 months now actually.
I also presume the privacy concerns will also skyrocket.
Privacy concern is there irrespective of which data type you're talking about.
Image data is better to private.
No,
or omics data is a little bit more sensitive.
No, not really. It depends on whom are you talking to. Maybe a Western audience, that's more nuanced. But if you read the India Privacy Act, it says that a large population in India is without any monetizable assets, which they can mortgage, and data is what it is, right? So a poor man on the street, whatever data that person's, whatever health data that person's is available in the hospital is that person's data. That's monetizable. So once you know that it's monetizable, they won't care what data it is, right? So, and in fact, that actually, and maybe to digress a little bit, there are challenges that will come in in the context of data privacy, etc. Because today you give so consent and all of those are a requirement, will be a requirement going forward, right? So today I give consent. 2 years down the line, I say I withdraw my consent, including retrospectively. So right to forget, that's there in, maybe you can Google up and you will see some articles. Right to forget is also a requirement that's coming through, right? So now in a trained AI model, how do I know how do we know which part of that weights is contributed by this person's data and how do I eliminate it is a problem statement now.
Did you guys try predicting meta learning? Like this becomes more closer to meta learning, what you have been saying, right? And you become task, each of the node becomes some kind of a task, and then learning and getting the model parameter, so that tomorrow new edge comes, you can initialize those parameters, right?
Yeah. So yeah, no, we have not tried that, and but there are, as I said, this entire federated learning. Today what we have, the biggest deployment of federated learning is your Google keyboards, right? Because the customization that happens local, because it learns your typing, PLEASE, PLZ, PLSSS, that customization is, as a consequence of, local learning, right? And there are other use cases perhaps, but your Google keyboard is one of the biggest example, right, of federated learning. And to date, the state of the art numbers is with the first algorithm, aggregation algorithm they worked with, which is your weighted average, right? But there are other algorithms coming through. So the entire area is, a lot of work that needs to be done research wise also, including this, right, in terms of meta and other, yeah.
You don't know whether the collaborator is a rogue collaborator or not. So that is one reason why so far we have not. I mean, we had a lot of deliberations on which should we add or not.
So that actually kind of takes me to again to digress, right? I mean, this is not part of the what I wanted to talk about. So privacy security does not inherently mean trust, right? Trust is a separate entity, especially when you have 71 kind of institutions who don't know each other, right? So what he talked about is a governor mechanism in OpenFL, wherein we talked about bringing in blockchain-based trust chain kind of a thing, right? So yeah, that is happening. Yes, yes. Yeah, that's happening already. So your DigiLockers tomorrow could be, you could have smart contracts running and then kind of, implementing a full. In fact, a lot of those data governance stacks, is based on blockchain, smart contracts, etc. Right? So that's a powerful means to do that, implement that. Okay. So this is a little bit about OpenFL. Shreyas and me did talk about what's the right order. Should we introduce the code and then talk about the workflows or the other way around? But I'll do it and then we'll talk about the code. So OpenFL also kind of went through its own iteration and improvements, right? We started with aggregator workflow, which is purely from, this is from federated learning's perspective, right? We did not think about OpenFL from a user's perspective, a developer's perspective. Purely from a federated learning experiments perspective is what we thought about, wherein there is this is one workflow. Again, do we want to get into the details is a bit of a question mark, and the colors don't help. The other one is a director envoy workflow. Now, this is the one that we recommend everybody to use because from a developer's perspective, this is fairly straightforward, right? So what it does is at the aggregator there is a director. I mean, and the terminologies are consistent with the kind of role they play. And at the collaborator there is an envoy, right? So what and then there is a API component, Python API component. So what it means is with a Jupyter notebook you can remotely connect to a director and then kind of execute your experiment. Whereas with an aggregator that's not possible. You need to be kind of have a login on the nodes on which the experiment's running and then kind of manage the experiment, right? So there are two workflows. Again, the details maybe we can talk about it maybe subsequently. But what we recommend is use the director envoy workflow. Now, what is a director envoy workflow? What is aggregated workflow? Kind of makes more sense in the context of the code OpenFL. And let's see if we can cover that. Right. So how to get started? It's all open source. Now, maybe few things that is not talked about in the deck. OpenFL is framework independent, right? Which means that you can start with a model that's been trained on, model that's been trained on TensorFlow, model trained on PyTorch, even Baidu's we have done.
So it supports today TensorFlow, Keras, PyTorch,
TensorFlow, Keras is PyTorch,
JAX, Flax.
Yeah, JAX, Flax. So you can train it. The central training you can do it on any framework, right? And then you bring it here and do the addition, the delta training, right? Federated training. So that way it is, framework agnostic, hardware agnostic. We have, we of course support the CPU, but we also support NVIDIA GPUs. We also support Intel's Havana instances. By the way, Sandhya, the co-author, she comes from the Abana team, right? So Abana is a ASIC accelerator for deep learning. The DL1 instances on AWS is where you can find the Abana instance. So it works on Abana HP also. So which means it's available on AWS. So DL1 instance, right? $13 per hour. Yeah. So, but the point is, from the OpenFL perspective, it is framework independent, hardware independent. That's how we kind of envisioned it. And there is, sorry, I kind of go back. Right, you can do a pip install OpenFL and it does it. There is a Docker version of it, right? And these are some of the framework JAX flags additionally, and OpenFL documentation. I'm the biggest critic of the OpenFL documentation. Enough room for improvement, especially when the community grows. But there is some documentation, right? I'll admit that. Now, who is using OpenFL? And this is of course, UPenn, which is the one on the top. But then we are also running a few challenges, and then there are these entities which are using. For example, I think I knocked off a few foils here just for time. We also had an experiment done with NASA with respect to using it for the astronauts, right? Training certain attributes for the astronauts. So there has been, we kind of been, so the intention here is, of course, we looked at it from an healthcare perspective because the impact is significant in healthcare, but we're not limiting the OpenFL to, or federated learning to healthcare alone, right? Retail, banking, banking also is one which is heavily regulated, and access to data is a problem statement. So you can use federated learning there too. No, OpenFL, the public, I mean, the non-security version of it does not need, it's not dependent on, right? But the security one, because it relies on the hardware security, that is on Intel, and that is also open source. Just the hardware you need to pay for. So this actually is a contest. Maybe I'm a little bit low on the information. So this one is a running competition, right? Every 6 months, every year, new challenge is put. Again, this is in so the FETS challenge, right? That's in collaboration with the UPenn. Every year a new challenge is put out, and then you can kind of participate. In fact, we worked with in India and IIT Chennai, for example, right? And a bunch of students we mentored, and they kind of did some work which got accepted, etc. Yeah. Yeah. Now this the Intel part, right? Now kind of I'll kind of use wear the Intel badge and then talk. Right? So one of the key challenges is with respect to the security, right? As I talked about privacy and security, right? Now privacy is a consequence. I mean, will be implemented as a consequence of some of those privacy preserving techniques, but security requires hardware guarantee, right? Your trust zone, right? Think of your trusted execution environment wherein you want to create a sandbox in the hardware itself, a sandbox which cannot be intruded into without adequate permissions. And that's what Intel SGX is, software guard extension. So we have done that extension. So the UPenn one, only the aggregator was secure. The collaborators were not running on secure machines. They were just using whatever machines they had. But the one that we did with Aster is end-to-end security, right? Wherein we actually sponsored machines for each of those hospitals. So hospitals did not have to pay money. So Intel sponsored money, and those machines were deployed and trained on these CPUs, right? And we also used it to kind of do some comparisons of what is the overhead of security. Security is like your insurance premium, right? Nobody likes it, but if you need insurance, you have to pay premium. So security does come at a cost on the compute, but what is that cost on the compute? Some experiments that we have done, right? So yeah, so with Intel SGX, we kind of stress a lot on this, confidentiality, model IP protected end to end, and integrity and attestation, right? And there is an entire, there is another, by the way, actually, again, I think I might digress and kind of dilute the message a little bit, but SGX is also based, I mean, that's the hardware component, right? Now, how many of you have actually kind of worked with ARM Trust Zone? Okay, so this entire security thing, writing for, writing secure code, is if you need a job which is kind of protected by ChatGPT generating code, look at writing secure code. That actually is, differentiation on coding, right? I mean, you are just a normal code, ChatGPT will replace you. Do secure coding, that actually is a differentiation. So the point, what I'm trying to say is, SGX earlier, if you have to kind of say you have an application and you want to run it in SGX, you have to refactor it, which is also true for the ARM trust zone. I don't know where it is today, wherein you need to partition your code into the secure and unsecure part, right? Not all part of your code is going to deal with secure data or the critical data. So you need to separate it out and then push the secure part of that into the trust zone, right? And that's because your, again, element of hardware design, there are constraints around how much of memory, how much of address lines, bus lines can be dedicated to the security, right? Unless until I say that entire CPU is, anything that runs on the CPU is secure, but then that comes at the cost of penalty. So security is like a flag, you switch on and then you get a secure execution, and that actually has certain implications on the hardware, as a consequence of which you need to refactor your code, your application. Now, as a very straightforward, nobody likes to refactor their code for running it in SGX, right? So we have actually built it on top of something called Grameen, Gramine, again open source. Just compile your application with Grameen and it runs default within SGX, right? And again, in the true spirit of open source, you can also extend it to AMD security. You can also extend it to NVIDIA. Does not have it yet, but maybe in 1 year, 2 year down the line they will have. You can also extend that Grameen to also cover NVIDIA hardware, right? So what it means is OpenFL. We have taken OpenFL, compile it with the Grameen, and that's what is running in the sandbox, which is protected by Intel SGX. The other piece is the only verified and approved, right? And that requires attestation coming in, right? Intel also has something called Project Amber. Again, I don't, you need not note down anything, but that's a layer of attestation built on top of SGX, right? So this entire attestation, certificates and attestation is happening in a secure environment, right? So the point is, what I'm trying to say is this entire end-to-end is protected, right? And it's protected in the sense audited, certified, except for some of those corner cases, but to a large extent, it's been audited, certified as secure enough, right? So what is Intel SGX? I'll kind of skip interest of time. And this is how it works. Let me see if, again, the colors are a little bit messed up. So this is actually your global model going to each of the, I think the machine will conquer the laptop. So that model going to each of the collaborator nodes and running in secure Intel hardware, right? So third generation scalable. So Ice Lake was a code name. Starting that, we have SGX on the servers. So that's where it runs. Maybe before. Again, there are links. And then this is the accuracy of it, as it converges kind of a thing, right? Again, colors, I don't think it makes any sense. There is, so there is an infographic which says how the accuracy improves as the number of rounds, as you go through a number of rounds. And these are some of the links to that OpenFL. And again, all of that is in open. So NASA that I talked about, this is the link, and there are further references there to see what exactly was done. This is the FETS, federated tumor segmentation. You go there and there is a yearly challenge. The 2021 is here, but I think 2022 also is there. White papers, yeah. So you have a bunch of materials there. Uh-huh.
Sort of foolproofing the access to it,
correct.
The model or the data.
Correct.
And this indeed, you can see that it's very localized, right? But from procedure of it, like the fact of it, how does it fly with both GDPR and even the Ministry of Personal Data Protection? Right? Is that something that is allowed?
So that actually needs layers on top of what we have implemented, right? So think of this as, yeah, this does. So think of this as an infrastructure to kind of implement your use case. Now comes the layer of how do you, which was one of the questions asked, how do you prove that this actually conforms with GDPR, conforms with the India's privacy thing? You need an auditable process. I know that there are standards coming through in ISO, etc., working on it to kind of say, what does security mean when it comes to running AI algorithms, right? So, in fact, Pushpak Bhattacharya, he heads the India AI standardization body. You can ask him what standards are coming on security, right? So there are standards coming, and as per that, there will be certifications that will come as a consequence, right? So this entire security is a good place to be in. if you are kind of wary of what ChatGPT will do to you. Right. So maybe one part that I missed, because the animation was poor there, and colors were poor there is, I mean, the way the data is pulled itself happens in a secure environment, right? You encrypt the data and say on a SGX capable machine, and that, so when it comes out of that machine, on the data storage servers, when it comes out, it's already encrypted. The decryption happens on the machine on which the federated learning runs. And that decryption happens within the SGX sandbox and enclave that we mention it as, right? So, and same with the AI models, right? So in transmission, be it the data or the AI model, it's all encrypted. And the decryption happens only within the sandbox, SGX protected sandbox, based on certain keys. And that key attestation, etc., is what I said, is also protected by SGX, so that, even if you go with, you are free to go with, say, AWS certification, I mean, attestation capability, or Azure's attestation capability. Azure is recommended because they have confidential compute enabled instances that you can use. AWS does not have it yet. Azure is good, right? So you can actually protect it, the entire, encryption and protection of the keys. Everything can be protected end to end. That's what we did with Aster. Just for so we did find, as consequence of the Aster experiment, we did see, what is the delta that, security brings in from a performance, right? Because if performance is your key, I mean, insurance premium is good, but if that's taking your entire salary, nobody will pay your premium, right? So the same thing, right? Security is good, but if it's hogging the entire compute, what's the point in having security, right? So we did that comparison. And at least to our satisfaction, Aster said that, they are happy with what they saw, right? I'll not quote the numbers because it's not legally approved for me to talk about it, but at least Aster said it's they are happy with what they saw. So it's not a big, and there are enough rooms for optimization to bring that headroom, I mean, that overhead further down. Yeah, both. Yeah, it's all encrypted. I mean, at the end of the day, it's all encrypted. Your decryption happens within the secure enclaves.
And in flight also, it's encrypted by TLS. So
yeah,
the models transferred also, that's
The model it's uses MTLS.
Using like Intel SGX remote attestation, I think I have seen a paper of USA Black Hat 2017-18. So in that, their research was on DNN reverse engineering on Intel SGX. They use performance counters and all, and they have successfully done
correct.
that.
Side channel and others, yes.
So how, you are telling, your model on SGX is totally safe. They have shown that they can reverse engineer the DNN altogether.
So that's 2017, and this is 2021. In the meantime, there are, security. When I say security, the moment you say, now quantum compute is coming in, how can you claim that everything is safe? Because quantum compute will pretty much blow away all your keys. I mean, all your encryption algorithms, right? So security is a constant. There's never a full stop when it comes to security stuff, right? So what you rightly said is the 2017 work. As a consequence of that, we have Ice Lake machine, which has addressed this problem statement. We have now Sapphire Rapids, I think the next week that announcement will come through, which is further improving on both the memory encryption and the compute CPU encryption. Plus, Intel also has a security champion challenge. I mean, I don't have the details, to be honest. Our CEO talks about it, wherein even if you are able to hack, we pay you money, right? So there is a security champion thing, right? We totally acknowledge. The moment I say, I have security, this is what it does, there is already somebody who is trying to hack into it, and somebody will succeed. And that's the nature of anything which we claim as secure, right? It's like protecting your house. So, I mean, can you really say that your house is fully foolproof? No, I mean, your security guard himself could be the one robbing at the end of the day. So it's always a challenge that way. So, and that's a nature. That's why I'm saying again, from a job security is good. Any other questions? Yeah, maybe Shreyas, can you just see on this machine, can we get that? So we had all the stuff on our laptop, but there too, there was some restriction because, this entire federated learning happens distributed, data flows across the network, and that actually has certain, requirement or minimum requirements on the kind of network and the network speed, etc. And we, at least outside, we were running into some challenges. So we thought we will kind of do a code walkthrough, right? But now that too. Oh, can we connect our laptop? No.
It's not. No, of course. So minimum certain guarantees, but
And that actually also was one of the areas that we looked in the context of Aster, right? What kind of compression, not just encryption, but also what kind of compression helps optimize the data that flows, model. So if you have the big models, again, we did it with Aster, and it was all very intranet, and they were okay with it. The moment you're doing it across institutions, it's flowing on public network, and you get billed for the data that is flowing.
of course.
And the network bill also is a key consideration, right? So as much as you can compress is a major requirement.
Yeah, I come from the other side, so we'll connect on that because I.
I talked about earlier is the speed in the local context.
Okay.
But even the overall federated learning context, network is a key consideration.
Definitely, I mean, for time critical application, latency is going to be a key constraint for you, right? I was just wondering that if it is not time critical, then also can the latency be as bad as for it to be if you're moving the model and
No, that's not. So
that's not right. So that's what it is.
For any federated learning stack, for that matter, you have enough of configuration on how much time, say, an aggregate has to wait for collaboration, right? That's not a problem statement.
But again, there are multiple layers to that, right? Like you have synchronous federation where the aggregator waits for every collaborator to come back. Otherwise, then.
So what I'm trying to get at is the role of network in this. So how speedy you want it to be, and if there is a
the network is important. I mean, so the network speed is important, and subject to your latency, you can configure what is those thresholds that you are okay with.
Okay.
So what he talked about is, as a consequence, what will happen to federated learning, right? In terms, if somebody is not responding back, how do you handle it in the federated when it comes to aggregation? So out of those 71 institutions, say one round, only 30 respond. The other 31 are 41 are still, computing and or it's on the network.
Retry policies and all those things.
So that kind of boils down to the error handling and how do you manage that?
Offline sort of buffering, and then when you connect,
then
you
many again.
Straggler handling.
Correct.
Makes perfect sense, right? Like you decide that for some rounds you don't want a poorly responding collaborator, and then handle it in a.
Or if the network is off, the network is just simply off. The network is down, right? So you don't want to lose that data or something that you're generating. So this happens for a lot of this edge computing kind of scenario, where the network is disrupted.
All of that are a requirement. I mean, whatever you do for your normal traffic, data traffic, ensuring that you don't lose data as a consequence, and all of that's applied to federated learning. But what is the threshold is configurable.
There are, I think, some algorithm which talks about asynchronous federated learning.
Yeah. Yes.
Yeah.
No, even with asynchronous, what do you do when they respond back? So how do you handle it? All of that is a problem statement. Some of them ignore. Some of them handle it in a different way, right? And again, you can go to multiple papers out there which talk about that. Yeah. So maybe Shreyas, you can quickly talk about the code layout and maybe walk through one quick example that we have.
So this is the GitHub repository for OpenFL. Not sure how clear it is, but so the basic code organization is most of the core OpenFL code, which probably people who want to run Federation might not be interested in, all inside the OpenFL folder. That's where the handling for some specific changes for the framework related things, right? Like if you have to support something with PyTorch or something with Keras, there's some kind of quirks that these frameworks come out with, which sometimes need to get handled. And then the aggregation algorithm that we want to use. Today we support EWC, Fed procs, and Fed averaging. a couple more on the way.
Yeah,
And
so
then
maybe I'll just paraphrase that a little bit, right? So there is a core stack part of OpenFL, right, which is basically handling the aggregators, collaborators, the communication between them, the aggregators, algorithms, so on and so forth. That's what Shreyas is talking about. That is this OpenFL folder. Somebody wants to know how exactly that stack itself has been implemented, you can get into that folder.
yes.
But most of us, if you only want to run the experiment, then there are other folders to, the OpenFL tutorial.
Yeah, I'll just so Raghu alluded to this fact that we had two workflows, right? One is the aggregator-based workflow, and one is the direct on interactive API is what we call it. So typically in the aggregator-based workflow, you kind of get into this OpenFL workspace folder and then replicate those workspace folders in the aggregator and collaborators and run those experiments. So there's no line between uh, the data science guy who's running the experiment versus the guy who sets up the infrastructure. So then we came out with something called a director envoy based workflow that will take care of setting up these infrastructure through the code itself via the notebook and other scripts that we have, and you can find those examples here. Right? Now here you can see there's a folder called interactive API, and there are other notebooks here. These other notebooks will be kind of deprecated because these use the very first version we came out with, where we used some
Aggregator
Python
workflow.
APIs that kind of simulate the aggregator based workflow on a single machine. So these notebooks was for that, and it kind of uses those APIs. So this will be very soon converted to the whatever the API today is supported, right? And then we have the interactive API. This is where we have most of the support. Raghu did mention that we are looking at many examples other than healthcare, but today it's heavily biased towards healthcare because that's where the requirement came from, right? So most of except some MNIST and other things, we don't.
There is a dogs and cats.
Yeah, exactly. Finally, that's what AI is used for. So true to that. So that is where we're using, right? I'll just come to some quick example. Probably take PyTorch tiny ImageNet and then explain the flow here. So the three components are the director, envoy, and workspace. I'll just come to the workspace in a bit, but director, you just specify the port and the shape and target. Basically, the parameters that you want to do. You can probably define your own parameters here and then use them in the envoy YAMLs as well, right? But for now, say this experiment, we use these. This is the port on which the director will run. But there are if you had observed the exam, the slide that Raghu showed, right? The director is actually an abstraction over an aggregator. So director has its ports where it has a port where it receives the MTLS from the collaborator, but the aggregator is another service that runs that requires another port for communication with the collaborator entity on the other side. So this is not that port. This is only the director port. The aggregator port is calculated by the code in a given series range of ports that's available, right? That's a config that's coming soon where you can actually select which aggregator port has to be selected. But for now, that is not the case. So this is the director director code, and you run that you run the script and it will run the director. FX is the CLI utility for Open. Then we have the envoy. So this is, I'll show you the diagram.
So this director envoy, the configuration that you're seeing is purely in the context of the tiny ImageNet, right? Now for a UNet fed running, that will look totally different, for example.
Yeah, and on the envoy, the major component here is the shard descriptor, right? How do you want to split the data? Say, for example, we are talking of some data that's publicly available. Say, for example, I'm just taking that example, and you want to run federation on that over 4 machines. Say maybe you want to experiment with non-IIDness where you have extreme classes on other end, right? But how do you now shard the data? The shard data code is in this folder. I'll go to that, but the important thing here is there's something called a rank and a word size. So 1, 1 means you're taking the first piece out of the entire thing. I mean, if you have one collaborator, it's 1, 1. If you have two collaborators, you will mention 1, 1, 1, 2 for the first collaborator and 2, 2 for the second collaborator by telling, you just like take the second piece from the entire.
So another way of looking at it is the short descriptor. It's kind of helps you with the simulation environment versus a real world environment. In a real world environment, each of the hospital has one single blob of data that you are supposed to ingest, right? And you don't need to shard it or whatever. But in a simulation environment, the same public data set, and that's what Shreyas was talking about. You may want to simulate it in different ways. Maybe even simulating the IAD distribution, the data distribution, etc. In which case the short descriptor comes in. So,
I mean, by the way, just talking of the IID simulation, OpenFL also supports a couple of different ways to simulate the data Dirichlet and the other methods for it. Right, it's a part of the code.
Font, I mean, even I cannot read it from here.
Not able to change it.
No, it's okay.
And then you start the envoy with this. So for each envoy, you have to specify which YAML that collaborator has to change, because that will decide the data it owns, right? So that becomes a key part of it. And then you have something called a workspace. This is essentially a
data science persons, which is where all your model related details are present. So your director and envoy is more the federated learning backend, right? Now the actual AI algorithm is there in that workspace.
So, I mean, if I have to broadly speak, it is different parts to it, right? Where once you want, I mean, where you want this to connect to the federation, you start the director, you start the envoy now, but how do you run your experiment? And this is a Jupyter notebook that's outside. So you want to first connect to the director and tell that I want to run this federation with this settings, right? Whatever it is. Then you have
load your model also, right? Whatever model you want to work.
yeah, coming to that.
Yeah.
Then you have a section where you want to register the data set, which is now getting sharded or used in those envoys, right? That is where the next part comes in. And you can have this class. There's a class that allows you to do any transformations you want on the data. The data is there, but you want to apply that a global transformation in all the data all the data that's available in all the envoys. And this is where this is the class that will allow you to create the train and the test data loaders per se, right? I mean, this is based on PyTorch, but we have examples that suppose TF data now as well. So the concept of data loader kind of goes away there. But but in PyTorch we are using this here, right? So that's the.
This transformation model could have been, envoy specific, because different
Correct.
code ID.
Correct. Absolutely. Yes.
Correct.
So it is there, right?
Yes.
Yeah. This is where this is an option given where someone wants to apply a global transformation.
Also I can specify.
Absolutely, yes. Sure. Including different tool chains or whatever. Yeah.
And this is where we define the model, and then you bind the model to the optimizer. And again, most of this, some of this we have created a wrapper over the optimizer, say the PyTorch or TensorFlow, but you can use them natively as well. In some of this case, we have made a few optimizations, and by using few Intel libraries, you can as well decide to skip it and use the native optimizer. Then you register this model to the interface that OpenFL provides. The OpenFL creates a dictionary of this model, so it can be moved around. In the the interface will define how that has to be used. And then the next part is you register the task. Right now the task can be, for in this case it is you train and then you validate. So those are the two tasks here. So we register those tasks with decorators provided here, and also specify the model, the data loader, the device that has to be used. The device can be a CPU, GPU, or a HPU here in this case. And this is the validation loop. And then you just create the experiment class and start the experiment. And today we support Tensor board as well, so you can see your metrics on Tensor.
So running it, typically a new intern coming into a team and starting on OpenFL by afternoon, right? I mean, morning they'll start with what is federated learning. By afternoon, they're able to run the experiment. At least this standard tiny ImageNet kind of examples, right? As you get into more complication on the kind of data that needs to be handled, the time required kind of increases. But this, forget whether it's OpenFL or some other FL, but for you to get an idea of how federated learning stack works, what is a common part which deals with the backend, the communication between the nodes, and what is the part which deals with the algorithm itself, it's a good reference for all of you.
That's it.
I mean, we also had a work. I mean, same thing we could have run, just that the machine we do have a challenge. Any questions?
What are the audit logs and all? Like, how do I say if I have to convince the IT team? Is there some provision over here?
Yeah. So the audit logs is, I mean, when the experiment is running, there's a lot of logs that come in, right? Number one. So that is something that they can tap into. Second, you can also run sniffers on your ports, right? I mean, see, for example, the Aster, whatever machines were in Aster, none of those machines had any port open. Right. So where is it? But you can sniff. You can run sniffers and check. What is the data that's moving out. Additionally, which is not there at least in this, and we have not actually spent time, is wherein we can provide hooks to kind of connect to other modules. That the hospital may have. And then give you all the additional information required to convince the hospital that there's no data leak happening. Okay. Any last question? Okay. Thank you. Okay. Somebody just woke up. Yeah, what is the impact to the patients? Now, for example, the UPenn that I talked about, the drug, I mean, the tumor segmentation improves by 33%. What better for a patient than having AI models which can detect 33% better as compared to without federated learning? Okay, thank you.